Welcome to Episode 12, What Serverless Computing Really Means. The term serverless sounds like a world without servers, but that's not the case. It means that the responsibility for managing servers shifts entirely to the cloud provider. You still run code, but you never handle the infrastructure beneath it. You don't think about provisioning, patching, or scaling because all of that happens automatically in the background. The provider ensures that compute resources appear when needed and disappear when idle. This frees developers to focus purely on writing business logic, what the code should do, not where it should run. Serverless computing represents one of the clearest examples of the cloud's promise, turning complexity into simple, on-demand capability. Serverless operates through an event-driven model. Instead of constantly running processes, you write small functions that react to specific triggers: an incoming message, a new file in storage, or an HTTP request. When the event occurs, the platform launches your function, runs it, and then shuts it down. This approach aligns perfectly with modern modular architectures where applications consist of many small components working together. For example, an online store might trigger a function to send a confirmation email every time a new order appears in a database. Event-driven execution ensures resources are used only when needed, and nothing runs idly waiting for work to arrive. Managed scaling is what makes serverless so powerful. Behind the scenes, Azure automatically provisions instances of your functions as demand grows and removes them when demand drops. You never set scaling thresholds or capacity limits. The platform handles it for you. If your app gets one request per hour or 10,000 per second, Azure adjusts seamlessly. This invisible elasticity ensures performance consistency without the burden of manual scaling. It's a direct expression of the cloud's promise. You gain the ability to grow instantly without ever touching infrastructure. For developers and small teams, this managed scaling removes one of the largest sources of operational stress. The billing model of serverless computing reflects its efficiency. Instead of paying for pre-allocated resources, you pay only for execution time and the number of requests handled. Azure Functions measure cost by the number of function executions and the compute time consumed. When your code isn't running, you pay nothing. This consumption-based model turns cost into a direct reflection of business activity. If your service is busy, you pay more. If it's quiet, costs fall automatically. It rewards lean design and encourages lightweight, efficient code. Understanding this billing rhythm helps teams budget with accuracy and align technical behavior with financial outcomes. Azure Functions are the heart of serverless in Microsoft's ecosystem. They allow developers to deploy individual functions written in languages such as C#, Python, or JavaScript. Each function runs independently and can be triggered by events from many sources, including HTTP endpoints, message queues, or storage changes. Azure manages deployment, scaling, and runtime automatically. Functions are grouped into function apps for organization and shared configuration. This structure enables modular development. Each function does one job well. Together, they form flexible systems that evolve quickly without large rewrites or infrastructure headaches. Bindings and integrations are what connect Azure Functions to the wider cloud ecosystem. A binding is a simple way to link your function to data or services without writing boilerplate connection code. For example, an input binding might pull data from an Azure storage blob, while an output binding could send messages to a queue or write results to a database. These patterns make integration fast and reliable. Developers can focus on logic rather than plumbing. With just a few lines of configuration, your code interacts with other cloud services securely and efficiently. Bindings are what make serverless not only simple, but also deeply connected. Stateless design lies at the center of serverless thinking. Because each function runs independently and may start on any instance, it cannot rely on memory from a previous run. Instead, any necessary state is stored externally, in databases, queues, or durable function workflows. Azure Durable Functions extend this model by allowing stateful sequences through orchestrations that manage checkpoints behind the scenes. This makes it possible to build long-running workflows like approvals or data pipelines while keeping code simple. Statelessness improves scalability, reliability, and fault recovery because each execution is clean, consistent, and independent of history. Cold starts are a common trade-off in serverless systems. When a function hasn't been used for a while, the platform may need a few seconds to initialize resources before execution. This delay is called a cold start. It's usually short, but in latency-sensitive applications, it can matter. Azure offers premium and dedicated plans that keep functions warm, reducing cold start times. Developers can also design around it by caching data or structuring workflows to tolerate slight delays. Understanding cold starts helps set realistic expectations and ensures the right performance profile for your workload. Security boundaries in serverless platforms follow the shared responsibility model but focus heavily on identity and access control. Since you don't manage servers, your focus shifts to securing inputs, credentials, and permissions. Each function should run with the least privilege needed to perform its task. Azure integrates with Entra ID for authentication, supports managed identities, and allows secrets to be stored safely in Key Vault. Functions should validate incoming data carefully because every event could be an attack vector. Designing with security-first thinking ensures that serverless agility doesn't come at the expense of protection. Serverless computing simplifies operations dramatically when used in the right context. It removes the need to patch operating systems, configure scaling rules, or manage capacity planning. Small teams can build production-ready systems without full-time administrators. It also accelerates development cycles as each function can be deployed independently without affecting others. For event-driven workloads, scheduled tasks, and microservices, serverless often offers the shortest path from idea to running code. It's the ultimate abstraction. Operations fade into the background so innovation can take center stage. However, serverless isn't always the best fit. Containers or virtual machines may be better when applications require constant uptime, complex dependencies, or long-running processes. Containers provide greater control over runtime and configuration while still offering automation benefits. They're ideal for predictable workloads that don't benefit from event triggers or frequent scaling. Serverless excels at spiky, unpredictable activity. Containers thrive with steady, sustained workloads. Understanding these boundaries prevents frustration later. The best architecture often combines both, functions for bursts of work and containers for continuous services. Cost control in serverless environments focuses on managing bursty traffic and avoiding unnecessary executions. While paying per run seems efficient, sudden spikes can still cause budget surprises. Use rate limiting, caching, and event batching to smooth traffic patterns. Configure alerts to detect abnormal usage. Evaluate function execution time. Every millisecond saved reduces cost. For some workloads, moving from consumption to premium plans provides both predictable pricing and performance benefits. Like any cloud service, visibility and control are key. A few hours spent tuning can yield dramatic financial returns over time. Practical serverless guidelines bring all these ideas together. Choose serverless when the workload is event-driven, intermittent, or highly parallel. Keep functions small, stateless, and focused on one responsibility. Leverage bindings to integrate quickly and securely. Monitor continuously and budget for performance plans when latency matters. Mix serverless with other models when appropriate, using the strengths of each. Above all, remember that serverless is about freedom from infrastructure and the ability to focus on delivering value. When used wisely, it turns cloud computing from a system you manage into one that works quietly for you. Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.